Okay, on to more complicated stoichiometry problems here. So one step in the production of copper is to heat copper 1 sulfide, Cu2S, with oxygen. This produces copper 1 oxide and sulfur dioxide gas according to the following reaction. And if we look, we've got coefficients here, so this is a balanced equation for this. So here's the copper 1 sulfide and oxygen reacting to form the copper 1 oxide and sulfur dioxide gas. All right, it says which is the greatest mass of SO2, that's our sulfur dioxide, that can produce from 15 moles of Cu2S. Okay, so what are we given? We're given 15 moles. Sorry, I'm having a really hard time writing today. 15.0 moles of Cu2S. We know we're looking for the mass, so we're looking for grams of SO2. So mole map wise, we're going to go from moles of Cu2S into moles of SO2 and then into grams of SO2. Remember, we can't go straight from moles of one substance into grams of the other substance. So this is a two-step conversion. The first one is our mole to mole ratio, which, remember, we always use coefficients for. So blank moles of Cu2S equals blank moles of SO2. So we look up at our balanced equation. There's a 2 in front of the Cu2S, so that means 2 moles of copper 1 sulfide. And then we have a 2 in front of sulfur dioxide, so this is a 2-to-2 ratio. 2 moles of copper 1 sulfide goes to 2 moles of sulfur dioxide. And then we need to do our molar mass of sulfur dioxide, because now at this point we're here, we need to get from moles into grams of the same substance. That's always molar mass. So 1 mole of SO2 equals blank grams of SO2. So that's 1 times sulfur and 2 times oxygen. Sulfur is 1 times 32.066. The mass of sulfur on the periodic table. And then we have 2 oxygens, 15.999. Remember, get those straight from the periodic table. So that's 32.066 plus 31.998. So you just need to add those two numbers up. 32.066 plus 31.998. And you get 64.064. So that's our molar mass of sulfur dioxide. Okay, so equation. Remember, this is where we stick our units in. So we were given moles of Cu2S, or sulfur, or copper 1 sulfide, and then we're trying to get into moles of sulfur dioxide, SO2, and then we're trying to get to grams of sulfur dioxide. So again, the top part of this is just our mole map here, and then we've just got to cancel out our units. We need to get out of moles of copper 1 sulfide, so we need moles of copper 1 sulfide on bottom, and then we need to get out of moles of sulfur dioxide, so we need moles of sulfur dioxide on bottom. Okay, so the other way to think about this, again, remember, is it's just our equivalent statements. So this mole to mole ratio, and then molar mass here, we've got moles of SO2 and grams of SO2, moles of SO2, grams of SO2. So at this point, now we can just stick our numbers in our substitute and solve stage. So we were given 15.0 moles of Cu2S. And our mole to mole ratio is 2 moles of SO2 for 2 moles of Cu2S. It's a 2-to-2 ratio. And then our molar mass of sulfur dioxide was 64.064 grams. And remember, molar mass is always 1 mole. Okay, so what do we need to do with our numbers here? we need to multiply 15 by 2, divide by 2, and then multiply by 64.064. Or you can understand that 2 divided by 2 is really like doing nothing, so you can kind of cancel those out and understand that really all you have to do is multiply these two numbers together. So when we do that, we get 190. Oops, sorry, 190. Wow. Can't read the calculator either, apparently. 960. Apologize, have no idea where I got that number. 0.96. Okay, significant digits. Our given has 3. Remember, mole to mole ratios are exact. And our mass has 5, which means we need to take our answer to 3. Then 9 rounds the 0 up. So our final answer is 961 grams of SO2. Okay. Number 11, carbon tetrachloride is a solvent which is used as a refrigerant and also as a cleaning agent. Prior to the 1950s, carbon tetrachloride was manufactured by the chlorination of carbon disulfide, but now is mainly produced from methane. And we're given both balanced equations here. And then it says how many grams of carbon tetrachloride can be produced from reacting 709 grams of chlorine with excess methane. So the first thing you have to do is figure out which of these equations you're using. And in the second equation it says it's now mainly produced from methane. So we know that this is the equation we need to use. And we got to figure out what we have and all that kind of stuff. So it says how many grams of carbon tetrachloride. Okay, so we got to figure out what carbon tetrachloride is, and it says it can be produced, so obviously it's one of these things on this side. And we know it has carbon in it, and we know it has chloride or chlorine in it, and tetra means 4, so here's our carbon tetrachloride here. All right, HCl is hydrochloric acid. And then it says from chlorine. So that means that we're going from our chlorine into our carbon tetrachloride, and it says with excess methane. So this is what we're worried about, from going from here to here in this second equation. So first of all, we know that we need to use this equation here. Okay, so let's get started. Givens. We know that we have 709.0 grams of chlorine. We know that we're trying to figure out grams of carbon tetrachloride. Okay, so mole map wise, which I'm going to write up here so I have more room, we're trying to go from grams of chlorine, and then we can't go straight to grams of carbon tetrachloride. We have to first go into moles of chlorine and then go into moles of carbon tetrachloride, and then we can go into grams of carbon tetrachloride. So if we look, that means that we have 3 conversions that we have to do. We have to do molar mass of chlorine, and then our mole to mole ratio, or our coefficients, to go between our 2 substances, and then we do molar mass again for the carbon tetrachloride. So this is a 3-step problem. So I'm going to actually start writing my equivalent statements up here because otherwise I'll run out of room. So the first one is the molar mass of chlorine. 1 mole of chlorine equals blank grams of chlorine. Remember, chlorine's a diatomic, so when it's in its elemental state, which means we actually have 2 chlorines, so that's 2 times 35.453. So 2 times 35.453 is 70.906. Remember to put that in your blank because that's your molar mass. So there's your first equivalent statement. And then the second equivalent statement is to go from moles of your first substance into moles of your second substance. So we're going from moles of chlorine into moles of carbon tetrachloride. And I leave the blanks there because we have to look at our coefficients in our balanced equation to figure this out. The coefficient in front of chlorine is 4. There's nothing in front of carbon tetrachloride, which means it's 1. So this is a 4-to-1 ratio. And then the last step is to do our molar mass of carbon tetrachloride. So 1 mole of CCl4 equals blank grams of CCl4. So that means we have 1 times carbon and we have 4 times chlorine, so that's 1 times 12.011, which is just 12.011. And then we have 4 times 35.453, which is 141.812. And then we need to add those things together, and that gives us 153.832. Don't forget to put it up in your blank. 153.832 grams. Alright, so now our equation. We have a 3-step on this one. This is as big as it gets so far. So we are going from grams. Goodness, that was awful. Let's try that again. Grams of chlorine into moles of chlorine into moles of carbon tetrachloride into grams of carbon tetrachloride, CCl4. Okay, so remember at the top here is our mole map of how we get from one substance to the next substance, and then we just need to start canceling our units out. So grams of chlorine on top, grams of chlorine on bottom, moles of chlorine on top, moles of chlorine on bottom, moles of carbon tetrachloride on top, moles of carbon tetrachloride on bottom. Grams of Cl2, moles of Cl2, moles of CCl4. And then we need to put our numbers in. So we are starting with 709.0 grams of chlorine. And it's always 1 mole of our substance, 4 molar mass. And then our molar mass of chlorine, which we figured out was 70.906. So we need 70.906 grams to go in here on the bottom. And then we go to our mole-to-mole ratio. There's 4 moles of chlorine for 1 mole of carbon tetrachloride. So that means the 1 mole of carbon tetrachloride is on top, and the 4 moles of chlorine is on bottom. And then our last one is our molar mass of the carbon tetrachloride. And remember, molar mass is always 1 mole. So we have 1 mole of carbon tetrachloride is 153.832 grams of CCl4, carbon tetrachloride. Alright, so now what are we doing with our numbers? 709 is going to be divided by 70.906, then divided by 4, and then multiplied by the 153.832. And let's see what we get when we do that. That equals 384.547. Last step, of course, is our significant digits in our units. So our given has 4, our mass has 5, our mole-to-mole ratios are always exact, and then our second molar mass has 6, which means we need to take our answer to 4. The 4 does not round the 5 up, so our final answer is 384.5 grams of carbon tetrachloride.